Alright. So section 6.3 is on page 334. It talks about undetermined coefficient. We did this before, but we're adding down the annihilator method, and we did that on a system of equations. Now we're going to do it on a single equation. This is then page 337. It says use the method of undetermined coefficients. So the traditional, to find, we just want the particular solution. Well, to figure out the particular solution, we need to figure out what this is going to yield. Let y equal e to the rt, or rx in this case. That's r cubed plus r squared minus 5r plus 3. And then notice if I let r equal 1, that will be a 0, so 1 works. So this is r plus 3r minus 1. And since that's an r minus 1, it's squared. So we know that we're looking at e to the negative 3x, e to the negative x, e to the positive x, and e to the positive x times x. Well, that doesn't repeat in there. So we know that the solution for the particular is going to be a e to the negative x plus b sine of x plus c cosine of x. Now, just a warning, they start writing those as c sub 1 now. You don't have to, it's the same thing, but that's what they start writing. So they drop the a and the b part. So nothing new, we did this already. Let's do it again. If I let y equal e to the rt, then in this case this would be r cubed plus r squared minus 2. Again, where this is equal 0, r equal 1 works. So this is r minus 1. This is r squared plus 2r plus 1 minus 1 equals 0. So that is r plus 1 squared equal 1. Let me just make sure. I see the mistake. That's plus 1 plus 1, so that's a negative 1. So we have r equal negative 1 plus or minus I. So we know r equal 1 e to the x and e to the negative x cosine of x, e to the negative x sine of x. And again, we have to figure that out to figure out if the particular solution needs to be modified. So that would be a plus, and that would be bx plus c e to the x. Again, the book will most likely write this as c sub 1 plus c sub 2x plus c sub 3 e to the x, which is the same exact thing, no big buzz, but there it is. I look at number 6 next. Find the general solution. Okay, well, this is a bit better. Why is that? Because that's r cubed plus, so here we know we have to find that. Again, 1 works. So we did this already. So we have e to the negative 3x, e to the x, and x e to the x. We noticed none of those are in there, so the general solution is y equal the homogeneous c sub 1 e to the negative 3x plus c sub 2 e to the x plus c sub 3x e to the x plus, and if we look at the homogeneous, That is c sub 4 e to the negative x plus c sub 5 sine of x plus c sub 6 the cosine of x. So the particular first, the homogeneous first and the particular right after. Same deal with number 8. We did this already on the previous page. Let's do it again. R cubed plus r squared minus 2. So here we'll say, well, let's see, 1 works. So we notice this is r plus 2 plus, that's r squared, plus 2r plus 1 equals 0. So that is r plus 1 squared equal negative 1. Square both sides and you get, so the fundamental set is e to the x, e to the negative x cosine of x, e to the negative x sine of x. And here we notice that the particular solution is a plus bx plus c times e to the x. Again, they would write the general solution y equals c sub 1 e to the x plus c sub 2 e to the negative x cosine of x plus c sub 3 sine of x e to the negative x. Now you could say plus a, but they prefer that you write c sub 4 plus c sub 5 plus 1 times e to the x. And that would be the general solution. Now, I did forget. To find the general solution, you find c sub 1 and c sub 2. I'm sorry, c sub 3 and c4 and c5, if you remember. In the general solution, we always find the coefficients. That's what I forgot. So let me rearrange this really quick. There's the fundamental set. And the particular part specifically is what I have to work on all by itself. Well, if I let y equal a e to the negative x, then y prime is negative a e to the negative x, y double prime is a e to the negative x, and triple prime negative a e to the negative x. And now if I put that in there, I will get, let's see, negative a plus a minus 5, so that's plus 5a plus 3a. And here we will say, well, let's see, that is 8a equal 1, a is 1/8. So we just figured out what, we call it a, you want c sub 5. That's 1 over 8. And to figure out the other two solutions, well, we're going to have to go ahead and take derivatives of the second homogeneous part. And that is y equal, you could call it a sine of x plus b cosine of x. I need 3 derivatives for this to work. So if I take the first derivative, that's a cosine of x minus b sine of x. Y double prime will be negative a sine of x minus b cosine of x. And that will be negative a cosine of x plus b sine of x. And now if I take those and I plug them in, so this says if you take 3 derivatives plus a derivative, so if I take negative a cosine of x plus b sine of x plus the previous one, plus 5 minus 5 times y prime wasn't minus, was it? Oh, it was a negative 5, so when you multiply this by a negative, multiply this by a negative 5, that would be a negative, and that would be a positive. Good. And 3 times y. And all of that is going to equal sine of x. So the cosine of x, negative a minus b minus 5a plus 3b. And as for the sine, we have a b plus 5b minus a plus 3a. So the numbers in front of the cosine must be 0. And the numbers in front of the sine must equal 1. And we get that from setting the equations equal. Now if I go ahead and solve the system of equations, multiply this by a 3, that becomes 6a plus 18b equal 3. So b is 3 over 20. And if I substitute that in, I'm going to get a to equal 1 over 20. So now that I know what those are, I could go ahead and say y equals c sub 1 e to the negative 3x plus c sub 2 e to the x plus c sub 3x e to the x plus 1 over 8 e to the negative x plus debating the number in front of the sign is going to be 1 over 20 sine of x plus 3 over 20 the cosine of x. And that's pretty much the entire solution. So yes, it's a bit long. Well, to save time, I'm going to leave exercise 8 as a practice if you want to look at it. We've done those before. I'm going to get to this annihilation method. And this is how it works. We've done some of that in our matrices. Annihilation, it matches the following. If you see an exponential e to the rx, to annihilate that, you would use d minus r times f, that will be 0. If you see a polynomial in general, okay, that's not very well. If you see a polynomial in general, you would take d minus r times, well, d minus r to the m, and here they say k, this k, is 0, 1, 2, 3, all the way to m minus 1. Just think of it this way. This m is always k plus 1. That will guarantee that you're going to have a 0. So if you're dealing with x squared, then you want 3 derivatives. If you're dealing with x, you need 2 derivatives. If you're dealing with a constant, which is x to the 0, say you take 1 derivative. If you see as sine or cosine of bx, then d squared plus b squared will take care of business. And if you see that multiplied by an exponential, then that will be d minus alpha squared plus beta squared. And if you see that multiplied by x to the k, then you raise that to the m power. And we're going to do some examples on each of those. Again, always think of it as whatever this power is, you're going to take one derivative higher. So here it says, find a differential operator that annihilate the given function. Well, fairly simple. If it's a quadratic, apply the third derivative. That'll take care of business. And if it's an exponential, take d minus 5 operating on e to the 5x. That will zero that out. Now for this, it's d3 because that's a second I was going to say a second order. It's this quadratic. And for this, it's d minus 1, and if you multiply those, it turns out that's really how you zero those out. Here, the e to the 3x cosine of x and sine of x, that will be d minus 3 squared plus 5 squared, but the fact there's an x there, we're going to go one power above that, which is a 2. And that's how it works. X squared e to the x, well, e to the x is d minus 1. The fact there's an x squared, you're going to take that and cube it. This is d to the 4th, and this is sine will be d squared plus 4 squared. And the fact that there is an x to the 1 in front of it, you go one power higher. So you could put them in order if you want. You could say that's d to the 4th, d minus 1 cubed. You could leave them as they are. It doesn't really matter. In any order you apply those, they will annihilate all of these functions combined or any combination of them. Now, to show how annihilation works, it's really nice. You don't need to worry about modifying. It figures that out on its own. So if I really wanted to use annihilation for this, this gives d squared plus 6d plus 8. And this gives d minus 5. And this gives d squared plus 1 squared. And this is really d plus 4, d plus 2, d minus 5, and d squared plus 1 squared. And if you really think about it, the solution to this would be y equal, this will yield c sub 1 e to the negative 4x plus c sub 2 e to the negative 2x. Now if you get to that the particular solution, notice what they want. I'll talk about that in a minute. This will be plus c sub 3 e to the 5x plus that's a 3, I think. Yeah, that should be a 3. Well, 3 or 5, it doesn't mean whatever that is. And any combination of those will be the sine and cosine. So that's going to be c sub 4, the cosine of x, plus c sub 5, the sine of x. Now, this is the entire solution. What they're asking for in these sections, they're only asking for the particular. There's the particular solution. Remember, this we got out of the homogeneous, and the particular gave this. Now, applying this on those will zero out everything. And if I go for 24, if I apply the annihilation method, I will take d squared minus 1, and here I will take d minus 1, but 1 powerless squared. So if you really think about it, now if I really want to clean it up, that would be d minus 1, d plus 1 into d minus 1 squared. So that will be d plus 1 into d minus 1 squared. That will zero all of that, will annihilate all of that. So the solution would be y equal, well, this is going to be c sub 1 e to the negative t. That should be cubed, right? When you multiply those, that should be cubed. Remember, one of those came out of, you guys gotta forgive me, old habits are hard to die. So that's x plus c sub 3 x e to the x plus c sub 4 x squared e to the x. And of course, the particular solution would be those. Because remember, we always find the homogeneous first and see if we need to modify. Here, you don't need to worry about modifying. This works perfect. Just need to know where the particular is, and there it is. And if I go for number 26, the same deal applies. This is d squared plus 2d plus 1. And this is simply d to the third. So this will be d plus 1 squared. That will annihilate the whole equation. Well, guess what? The solution to that is this part will give c sub 1 e to the negative x plus c sub 2 x e to the negative x plus c sub 3, let's see, the second derivative, that will be x squared plus c sub 4 x plus c sub 5. And again, the blue part is the particular, that's all they want. So you could just highlight that, say that's the solution, if you really want. Almost done. And if I want to use annihilation on this, the d squared minus 6d plus 10 will eliminate the homogeneous part. And here we have d minus 3 and this will be d squared. That'll annihilate the right side. And that's pretty much going to equal 0. So the solution is that y equal, and if I only want, I know that there's no way this is going to be part of that. So they're negative p. So that's going to be c sub 1 I added one extra term. C26. Oh, that's right. That's it. Okay, I figured out my mistake. That was a 3. Now I feel better. Okay. So remember, you take an extra derivative to annihilate a quadratic. Here, you take an extra derivative to annihilate a constant. So the constant is really c sub 1 plus c sub 2x plus, and to really get this part, that is, that's c sub 3 e to the 3x. Again, there's no way that could be part of this, so there it is. And same deal with this one. If I really wanted to work this out, the annihilation of this, that's d cubed plus 2d squared minus d, which is d into d plus 1 d squared plus 2d oh, I forgot the 2. Never mind. There we go. And that's really d squared into d plus 2 minus d plus 2. So that is d plus 2 into d squared minus 1. And this is simply d minus 1 times just one derivative for that. So you notice here, if you really work this out, this is going to be d plus 2. This is d minus 1, d plus 1. Well, here, you'll notice that part of the particular solution is one of those. So when you get to the particular, you're really looking at e to the x with an x, and that's just a constant. You could write it all out and just point that out if you wish. That's the same thing I used.